Okay, so we are looking at recurrence relations for linear growth. Here is a sequence for linear growth. 2, 4, 6, 8 and 10. Now we want to work out how to find the third term only. Okay, we know that this third term is going to be 8. So we look at the recurrence relation. Our initial value is 2. Then every term after that we are adding 2. So our initial value, V0 equals 2. We know that equals 2. And the way we can write this process is the following. V1 equals V0 add 2. We know that equals 4. Now that term is V1. So now we can substitute V1 back into the sequence where V2 equals V1 add 2. And that equals 6. Now there's another way we can actually write this process. V0 also equals V0 add 0 multiplied by that common difference of 2. For the next term, V0 add 1 multiplied by that common difference equals 4. And once again, V0 add 2 multiplied by 2 equals 6. And as you can see, all that text in the black writing is changing. Now that's what we had before. Let's go to the third term and see what happens. V3 equals V2 add 2. We know that equals 8. So that's what we're trying to find, that third term in the sequence. But it can also be written like this. V0 add 3 multiplied by 2. And what we're trying to do is figure out a way on how we can actually get 8 straight away without having to go through each term. As you may notice, this value increased by 1. Okay, where you see that black text from 0, 1, 2 and 3 all the way down. This value increased by 1 and it is linked with n, as you can see next to V, where we have the 3. And 8 therefore is the third term. And as you can see, the common difference of 2 appeared each time. So now we can find a rule to actually find that third term. It's known as the explicit form, or the rule for the nth term, where we have Vn equals V0, add n, and that d in red is the common difference. And note that n is multiplied by d. Therefore, in this case, our recurrence relation was V0 equals 2, so our initial value was 2, then V, n add 1 equals Vn add 2. In the explicit form, that is Vn, okay, what that term value is, equals V0, the initial value, multiplied by 2, multiplied by n. N being the number in the sequence. Now, here is how we actually go from the general form of a recurrence relation, so where we have the initial value, then each term after that, into the explicit form and rule. So we have the recurrence relation and the explicit form or rule. So this next step is going to show you how those values move. So as you can see, that place value has moved. The initial value has moved from the initial section in recurrence relation down to the explicit form. And then we've got n, which is the number in the sequence, and the common difference at the very end. Now, explicit form for linear sequences. So we have linear growth. As you can see, we are adding the term value multiplied by the common difference. With linear decay, it's the other way. We are subtracting. And that is basically linear growth and decay in the explicit form.